Hello everyone, welcome back. In this video we are going to learn another important concept in Java multithreading, that is Executor Framework. So we will see with some practical examples and clear explanation. So subscribe to the channel to keep learning and growing your Java skills. So let's get started. So Executor Framework in Java. So you imagine like your Java application suddenly receives 10,000 request or 10,000 tasks. Okay, so what would be your next step? Will you create a new thread for each task, like 10,000 threads? So technically you could try creating a new thread for every task, but creating threads has a cost, right? Each thread consumes system resources, and managing thousands of threads manually can quickly become inefficient and very difficult to control those things. So what if we could create just a small number of worker threads and reuse those same worker threads and simply give them new tasks whenever they become available? Okay, so you think like you have 4 worker threads, okay, 4 worker threads, and you are giving some task to this worker thread, let's say 100 tasks at a time. So once this all 4 workers completed this 100 tasks, then again you are giving 100 tasks. Likewise, you are completing 10,000 tasks with the help of these 4 reusable worker threads. That is exactly the problem the Executor Framework helps us to solve. Okay, so in this video we will understand why thread pools are useful, how Executor service works, and how to create a fixed thread pool. So the important difference between execute and submit method, and one method you should never forget when you are finished using an executor service. Okay, so let's start with the problem of creating threads manually. Okay, so until now we have created threads manually using thread class like this, right? So for a smaller number of threads, like this is perfectly fine for learning and for some simple use cases, okay? But imagine creating a new thread for every incoming task. Okay, so you imagine like you have some application and you are having some task here, different options, different buttons, everything. You have different tasks, and for all those tasks, okay, it is like very difficult to create a separate thread for each task. So for a small number of thread, this is fine. Okay, so thread creation is not free. Threads consumes what? Memory and operating system resources. Okay, so if we create too many threads, we can increase context switching. Okay, this is an important term. So context switching will increase. It will consume significant memory. Consumption of memory will increase. Thread creation overhead. Okay, so this will reduce what? Reduce performance of the application. So we also have to manage the life cycle of those threads, right? So instead of thinking one task means one new thread, we can separate the concept of task from threads. Okay, what we used to do, we used to create one task, right? And we are assigning this task to one thread. So we can separate this concept of task from the thread that execute those tasks. Okay, instead we will keep on providing the task to different threads. So that leads us to the thread pools. Okay, now let's understand what is thread pool. Okay, so a thread pool maintains a set of worker threads. Okay, so worker thread means what? These are the threads which can be reused to execute multiple tasks. Okay, so you imagine like we have 3 worker threads. Okay, worker 1, worker 2, and worker 3. So these are what? These are worker threads. Okay, So on first go, worker 1 will do one task, worker 2 will do another task. Likewise, this 3 worker thread will complete 3 tasks. And once these 3 tasks are completed, again these 3 worker thread will get new 3 tasks. Likewise, they will complete all tasks. So these worker threads are getting reused. Okay. So instead of creating a brand new thread for every task, we submit task to an executor. Okay. So executor available worker threads take tasks and execute them. Okay. So when a worker finishes one task, it can be reused for another task. If all workers are busy, okay, you imagine like if all workers are busy and you have additional tasks. In such cases, additional task can wait according to the executor queuing. Okay, there will be queue in which task will be waiting. And configuration strategies. So this gives us much better control over concurrency and thread lifecycle. Okay, so you remember the key idea is don't necessarily create a new thread for every task. Reuse a controlled set of worker thread for completing those tasks. Okay. Now, so this is the fundamental difference. With direct manual thread creation, we explicitly create thread objects and start them ourselves. We will use a concept of thread pool. See, previously we used to do like this. For each task, we were creating new thread. But now we are creating a thread pool of, let's say, 5 thread pool of fixed number of worker threads. Okay, it can be any number depend on the executor framework. Okay, so with the thread pool, we submit task and allow the executor to manage the worker thread used to execute this task. So these 5 tasks will get executed by this fixed number of worker threads with the help of executor. So this separates 2 responsibilities. Okay, we define what work needs to be done. Okay, this is what work needs to be done, that is task. Okay, and the executor service. Okay, here I will write executor service. What it will do? It will manage, executor service will manage how that work is executed by its worker thread. How these 5 tasks will be executed by the worker thread is managed by executor service. So this makes concurrent code easier to manage and scale. Okay. Now we will see what is executor service. Okay. So executor service is one of the core interfaces in Java's concurrency utilities. So it provides a higher level way to manage asynchronous task operations. Okay. So instead of manually creating and starting individual thread objects, we submit task to the executor service. We will submit task, and responsibility of assigning this task to a worker thread is a work of executor service. Okay, so the executor will manage the worker threads. It can reuse those threads across multiple tasks. And when our application, okay, manage our reuse threads, okay, and when our application is finishing submitting work, okay, we have provided all tasks, then what executor service will do? Okay, executor service also provides methods for managing shutdown. Okay, so now let's see, and it belongs to java.util.concurrent package. Okay, so this is like thread pool, fixed thread pool. Okay, so one simple way to create a thread pool is using this method executor.new fixed thread pool, and here we are providing the size of the thread pool, how many worker threads will be there in the thread pool. So this is the thread pool. Okay, and how many worker threads we are providing here? So we have provided 3, that's why we have 3 worker threads to work on the different tasks. Okay, so this creates an executor service, okay, backed by a fixed size pool of 3 worker threads. So the pool can execute up to 3 tasks concurrently. Why? Because we have 3 threads, 3 worker threads. Okay, assuming tasks are available and the system can schedule the workers. If more tasks are submitted while all 3 workers are busy, then the additional task will wait in the executor queue. There will be queue. Okay, so let's say we have more than 3 tasks and all worker thread are busy, then those additional tasks will wait in the queue, executor works queue. Okay, until when it will wait, when this additional thread will wait, until a worker thread become available. Okay, so what happens if we submit 5 tasks to a pool containing only 3 worker thread? Okay, that is the question. So we have 3 worker threads and I am providing 5 tasks. How it will manage? Okay, so suppose our fixed thread pool has 3 worker threads. Now we submit 5 tasks. So will Java automatically create 5 worker threads for the fixed pool or what? So the answer is no. At most 3 worker threads from this pool will be available to execute tasks concurrently. So the remaining tasks, okay, will wait until one of those workers finishes its current task. Okay, so we have 3 worker threads. Okay, so each of these thread will pick one task. So 3 tasks are working concurrently. We have 2 remaining tasks. So these 2 tasks will wait in the queue until any of the worker thread finishes any of the tasks. Likewise, this 3 worker thread will complete all these 5 tasks. Okay, so the same worker can be reused for another queued task. Okay, so same worker thread are being used for this another task. So this reuse is one of the major benefit of using thread pool. Okay, so there is one method called execute method. Okay, so one way to submit a task is using execute method. This is one way. Okay, execute accepts a runnable task. So inside execute we are passing a runnable task. Okay, so this is like task that will be performed as part of the worker thread provided by the executor. So execute accepts a runnable task. This task is submitted to the executor. Okay, and this task will be executed by one of the worker threads. Okay, so notice something important. We are not creating a thread object by ourselves. We are simply defining a task here. What task needs to be done? Okay, and the executor is deciding which worker thread will execute this task. Okay, and also this execute method will return void. It will return void. Okay, so we do not receive a future representing the submitted task. So let's say if you are having some task, you are expecting some return value in future. In such cases, we will use another method. And let's say you have some task for which you don't want any return value, then in such cases you can use execute method. Okay, so suppose if you want to return something as part of this task after completion, then you will use method called submit. Okay, so you will call executor dot submit like this. Okay, so this is another method for providing task. Okay, so keep this difference like it. Submit returns value and execute returns void when we will see the difference between execute and submit. Okay, so this is the comparison between execute and submit. So execute accepts a runnable. Okay, execute what it will accept? Runnable, we have seen in the example. So with the help of runnable, we were providing the what task needs to be done. Okay, and it returns void. Okay, and it is useful when we simply want to submit a task and do not need a future representing that submission. That means we do not want any future output. That's why return type is void. Okay, and submit supports both runnable or callable. Okay, so these are tasks. So it will return a future. Future means what? Future. So whatever object or anything we are getting as a return after completion of task, those will be stored as part of future. So we can get those values by calling like future.get. We'll see. But you remember for now, like we can get the value with the help of future. Okay. So that future allows us to track the task, and for callable, retrieve a result. If you want to get result, use callable. Okay. So simple memory trick is execute means submit work without a returned future, and submit means submit work and receive a future. Okay. But there is another behavioral difference involving exceptions. Okay. That is useful to know. Now we will see the exception. Okay, so there is an important difference in how task failures are observed. So if a task submitted using execute, okay, it will throw an unchecked exception. Okay, execute method, we have submitted task, then it will throw unchecked exception that escape the task. It is handled as an uncaught exception. Okay, on the executing worker thread. And with submit, exception will be captured as part of the future, because submit will return future, and in that future we will be having the exception or the result. Okay, so when we call future.get method, the failure can be reported through an execution exception. This means that if we use submit and never inspect the future, task failures can be easier to overlook. Okay, if you are getting some exception in the future and we are just ignoring the future, then we cannot see the exception if we are using submit. Okay, so future is not only useful for result but also to see the exception part. Okay, it is also important for observing task completion and failure. Okay, now we come to one method I mentioned at the beginning. Suppose all of our submitted tasks appear to be finished, but our Java program is still running. Why? A typical fixed thread pool uses worker threads that remain available for additional tasks. Okay, so those worker threads are normally non-daemon threads. So executor, what it will do, executor service will create a worker thread. Even if you have completed all tasks with the help of these worker threads, this will be treated as non-daemon, and JVM will not terminate. Program will still run. Okay, program will be still running. Okay, so if you forget to shut down the executor service, okay, so this will create a JVM alive. Okay, that is why proper executor service shutdown is necessary. We should shut down. Okay, we need to shut down the executor once all tasks are finished. Okay, so to initiate an orderly shutdown, we call shutdown method. So we have shutdown method executor.shutdown. This will start the shutdown process. Okay, so after shutdown is called, the executor service stops accepting new tasks. Okay, and tasks that were already submitted are allowed to complete. Okay, so when we call this method, whatever tasks are already under process by the worker threads, those will be finished, but executor will not accept new tasks. Okay, and once those tasks finish and the worker thread shut down, the executor reaches the terminated state. An important point is that shutdown does not necessarily block the current thread until every task finishes. Okay, it initiates the shutdown process, and if we need to wait for termination, executor service provide additional methods such as await termination. Okay, so after shutdown, no new task accepted and previously submitted task will continue. Okay, and executor terminates once this submitted task will completed. Okay, now there is a quick question. So let's test your understanding. We submit task 1. Okay, so here in this line we are submitting one task, that is task 1. Then we call shutdown, and after that we are trying to submit another task, that is task 2. So what will happen to this task 2? So this new task will rejected. Why? Because the executor is no longer accepting new task submission. So with the standard method shown here, attempting to submit a task after shutdown result in, this will provide one exception called rejected execution exception. So always remember, shutdown does not mean cancel all previously submitted tasks. It means it will stop accepting new tasks and it will allow already submitted tasks to proceed according to the executor's orderly shutdown behavior. Okay, so it will first finish all the submitted tasks, then it will start the shutdown process, and it will not take any new task. Okay, so we have two methods, shutdown and shutdownNow. Okay, so shutdown performs an orderly shutdown. If you want to do orderly shutdown, just go with the shutdown method. Okay, so previously submitted tasks are allowed to continue, and shutdownNow is more aggressive. So this is like more aggressive. Okay, what it will do, it will attempt to stop actively executing tasks. Okay, how it will stop the executing task? By interrupting worker threads and return tasks that were submitted but never started. Okay, so but shutdownNow does not guarantee that every running task immediately stops. As we learned earlier, interruption is what? Cooperative. So a task must respond appropriately to interruption. So do not think of shutdownNow as a guaranteed force kill down. Okay, so this was the difference between shutdown and shutdownNow. Now we will see, when we create threads manually, we are directly responsible for creating and starting those threads, right? This is useful when learning how thread works and can still be appropriate in some situations. Okay, but for managing many independent tasks, executors provide a higher level of abstraction. Why I am calling abstraction? Because we are not managing the threads. Executor will manage those worker thread. We will just be providing the task, what task needs to be done, and assigning task to a worker thread and managing those thread is a part of executor service. Okay, so we focus on defining and submitting task, and the executor handles worker thread management, reuse, queuing, and lifecycle controls. So this separation between the task and the thread management is one of the biggest advantages of the executor framework. Executor framework. Okay, so here is the simplest way to remember the executor framework. So we define tasks using runnable or callable. Then we submit those tasks using execute or submit method. Okay, then executor service will manage those tasks with the help of different worker threads provided in this new fixed thread pool, and those worker threads will be reused for completing additional tasks. And when we are finished submitting tasks, we initiate proper shutdown. So instead of thinking I need to create another thread, start thinking I have a task which executor should manage its execution. Okay. So that is the shift from low level thread creation to higher level concurrency management. Okay, why I'm saying higher level concurrency management? Because the creation of thread and managing worker threads are being taken care by the executor service. We are just providing tasks, what task needs to be completed, and those are handled as part of executor service. That's why I'm calling higher level concurrency management. Okay. Now we know how to create a fixed thread pool. But here is the next question. Should every application always use the same type of thread pool? What if we need a pool that can grow when needed? Or what if we need only one worker thread, so task execute sequentially? Or what if we need to schedule a task to run after a delay or repeatedly at fixed interval of time? So Java provides different executor types for different concurrency requirements. Okay, so understanding when to use each one is the next step in using the executor framework efficiently. So that's all for this video. I hope you now have a clear understanding of the executor framework. Thanks for watching, and I will see you in the next video.